The screencast discusses the paper with real-time examples. The first paper that we are going to consider is fault detection in multi-threaded C++ server applications. The paper addresses faults that occur in concurrent programming. It discusses briefly on race conditions, deadlocks, and C++ specific memory-related issues on destructors. It also discusses briefly on hardware-related CPU logs. The screen shows the results of 8 test cases that were run on C++ server applications, with each histogram bin representing hardware logs, the false positive on destructors, the correctly reported data races. The results shows clearly that Valgrind is efficient in finding deadlocks, race conditions, and issues related to hardware logs. The second paper we are going to discuss is static memory leak detection using full sparse value flow analysis. Here we use a Valgrind based Saber detector. The steps involved are pre-analysis, build full sparse SSA, build the sparse value flow graph, detect leaks via graph reachability on the build graph. Let's see the steps involved with a real-time example. The first phase is the pre-analysis phase, where we remove the contents that are not required for us, and also we remove those regions of the code that doesn't involve static or dynamic memory allocation. The second phase, we try to build a sparse SSA, that is a static single assignment flowchart that tells the memory allocation flow. The third step, we try to build a sparse value flow graph that will tell the memory allocation flow. Here we try to understand the memory allocation reachability. If there is a highly distant memory allocation region, it means that there is a memory log. Hence we try to efficiently identify the memory allocation leakage. The next paper that we are going to discuss is using Valgrind to detect undefined value errors with bit precision. The paper discusses mainly about the memcheck operation of Valgrind and says how it is effectively used. The 4 techniques that are discussed are the reachability check on static allocation, heap allocation tracking, defineness check, check for memory operations. Let's see what these operations are in detail. The first one is reachability check. It means that the memcheck operation keeps track of all the static allocation that we do in our program. The second is heap allocation tracking. The memcheck operation will keep track of all the heap allocation, that is the dynamic memory allocation that we do in our program. The next operation is defineness check. Valgrind, when we use memcheck, will see if all the memory allocations or the memory access that we do using the variables in the program are correctly defined. The next operation is check for memory operations. Valgrind, when we use memcheck, will validate all the memory operations like string copy, memcopy, memmove, etc. The figure describes how, if memory check was used efficiently, can detect more errors that were uncovered even during the primary phases. We have a C program, valgrinddemo.c, which is customized to demonstrate how to detect and correct memory leakage and other memory related issues in a C program using Valgrind. I have a structure, Valgrind demo, with 2 variables, value of type integer and key of type double. I have a method, initialize structure, that will initialize an array of structure of given size of type Valgrind. In the section 1 of the program, I have a pointer ptr of type Valgrind demo that points to an array of structures of type Valgrind demo and of size 10. Section 2 tries to write to an invalid memory segment indexed at index 11. Section 3 tries to read from an invalid memory segment indexed at index 99. In section 4 of the program, we are trying to do a memory copy of overlapping segments, which is a huge threat as it results in data loss. In section 5 of the program, we are trying to access a valid index that was not initialized. which might result in fetching invalid data at real time. In section 6 of the program, we had a pointer that was initialized to an array of structures of size 10 that is not freed yet. Let's try to compile and run this program. Even though we had many critical memory related issues in the program got executed successfully. If these memory related issues are not addressed properly, it might result in series of errors and issues like segmentation fault, degrade in performance of the system by huge margin, and an inefficient memory management by the program. Now let's see how Valgrind helps us detect efficiently the memory leakage and other memory related issues in our program. Valgrind uses dynamic binary translation to provide complete control over a program. To do this, we request Valgrind to do a leak check over our binary. As we see in the screen, Valgrind efficiently lays out in a clear descriptive language all memory related issues in the program. Now we see Valgrind reporting the invalid write and read operation that we performed in our program. It also reports the source and destination memory segment overlap that we tried to do using memory copy, and it reports accessing uninitialized value at index 6, and it also gives a heap summary that we haven't freed the 160 bytes that we allocated. As we see, Valgrind gives a clear description of all memory related issues using heap summary, leak summary, and total number of errors that occurred at different contexts. Let's try to address these issues in our program. So the first issue is the invalid read and write access that we performed at index 11 and 99, as these indexes are invalid. So the second issue is the invalid memory copy that we perform using memory copy operation. As we know, memory copy of overlapping segments is invalid. Let's try to do a memory move, which is a valid memory operation. So let's try to fix this issue of accessing uninitialized pointers by calling our initialize struct method that will initialize the array of structures. The last issue is heap size not freed error. Let's try to call the delete method on the pointer ptr that will release the allocated memory. As we have fixed all the issues reported by Valgrind, let's see the memory management of our program using Valgrind. Valgrind reports that 0 errors, and it also says all the allocated memories are freed, which is good. Thanks for watching the video. Hope you enjoy the session.